we have variable acceleration here, because when you differentiate, although this will become constant, we'll have a function of t for j. So variable acceleration, just worth just shouting out at the start. We're asked to show that p is never stationary. So the only way it could ever be stationary is if vector v is equal to 0, 0. So I'm just going to focus on the simpler one. We require 1 minus 2t equals 0. Actually, I will write the other one. And 2t squared plus t minus 13 equals 0 for p to be stationary. Now 1 minus 2t equals 0 implies that t is equal to a half. But when t is equal to a half, 2t squared plus t minus 13 is not going to equal 0. That's going to be the outcome. So 2 times a half squared, which is just a quarter, so 2 divided by 4, plus a half minus 13 is minus 12. So components are never 0 at the same time. It's only 2 marks. I think I'm going a bit over the top now. And P is therefore never stationary. On to part B. Find in terms of I and j the acceleration of P at time t. So this is given by the derivative dv by dt. And I can differentiate each term. So I've got my 1 minus 2t differentiated gives me minus 2, which is minus 2i. And then my other 2t squared plus t minus 13 differentiated is 4t plus 1j. That's my answer. We're now told that the mass of P is 0.5 kilograms and determine the magnitude of F when P is moving in the direction of the vector minus 2i plus j. First of all, I'm going to write down what F is in terms of T. So it's F equals ma, and therefore it's 0.5 times our answer to this. I'm going to write it as a column vector now because it hasn't specified. I'd always just find that a little bit easier. So minus 2 times a half is minus 1, and then 4t plus 1 times a half is 2t plus a half. So we're left to find the time, and then we can work out f as a vector and hence the magnitude of f. Right, so it's all about the fact that p is moving in this direction. When p is moving in the direction minus 2, 1, b is going to equal some constant times minus 2, 1. I think it's going to be positive because otherwise you'd probably say it was moving in the direction 2, minus 1. You wouldn't specify it as minus 2, 1, but that's not going to be a big deal. I can take, therefore, my velocity here, and I can say that, therefore, 1 minus 2t is going to equal minus 2k, and 2t squared plus t minus 13 is going to equal just k. And then I think the easiest thing to do is substitute in for this one. So 1 minus 2t will equal minus 2 times 2t squared plus t minus 13. Quite like you doing it using k, it sort of naturally works out. There's other ways you could do it. So you could spot that the x component of the velocity is going to be minus 2 times the y component of the velocity, which would take you straight there. But I feel like k is a nice, safe way to do it. So we've got a quadratic to solve. Let's expand the bracket first. And then rearrange it. I'm going to make 4t squared positive. Oh, brilliant. So these cancel. 4t squared is therefore going to equal 25. T squared is going to equal 25 over 4. T is going to be the square root of that. It's going to be, well, plus or minus 5 over 2, but reject the negative, of course. I don't know whether you even need to say that, but I always just do it just to be careful. So T is equal to 5 over 2. And here, F, we're back to F now, will equal minus 1. 2 times 5 over 2 would just be 5. So it's going to be 5 plus a half, or 11 over 2. And therefore the magnitude, right, well, I'm going minus 1 in the x direction, and then I'm going up by 11 over 2. So we can use Pythagoras' theorem to find this overall magnitude. You can make it minus 1 if you want, it'll give you the same thing. Why did I just leave it as 5.5 now? So 5.5 squared plus 1 squared, which is just 1, gives me this. Square root it, 5.5901. So F, that means the magnitude, or you could write this equal 5.59 newtons. On to the last part. So given some information here, when t is 1, P is at the point with position vector 1, 6, j. We're asked to determine the bearing of P from O at time t equals 1.5. Okay, well, I brought the velocity down. I am actually going to just copy this as well. So this is all about finding basically the displacement vector, or the position, I suppose you could call it. And that's going to be r. So, or you could call it s underlined, but I'm going to call it r here. But that will be dr by dt, or ds by dt will equal v, and so therefore we need to integrate. Now I'm going to integrate it just using columns. So 1 minus 2t, 2t squared plus t minus 13 integrated with respect to t. This will give t minus t squared, 2/3 t cubed plus a half t squared minus 13t. Don't forget your constant, which is now a vector. We're told this information here. No, I don't need to write that down again. Therefore, I can say that 0, 1/6, because that is the position vector 1, 6, j. Let's do that again. That will equal, I'm going to substitute in for 1, so I'm going to get 0 here. And then over here, I'm just going to get 2/3 plus a half minus 13. Just ignore the ones because I'm just timesing through by 1, or 1 squared. It's the same thing. So what was it? 2/3 minus a half. Sorry, plus a half minus 13, which gives minus 71 over 6 plus c, which means that c is going to equal. So I'm going to subtract this 0 minus 71 over 6 from both sides. I'm therefore going to get a 6 plus 71 over 6, which is 72 over 6, which is 12. So we've got our constant. R will therefore equal this t minus t squared, that's fine. And then 2/3 t cubed plus a half t squared minus 13t plus 12. We're asked to determine the bearing of P from O at the time t is equal to 1.5. So what we really need is the position. Where is it? And we can do that by substituting in 1.5. So we've got 1.5 minus 1.5 squared, which gives minus 0.75. And then, okay, for this one, I'm just going to use the answer button to help make it a bit quicker. So 1.5 equals, and then 2/3 answer cubed plus a half. I'll just write 0.5 answer squared. Okay, do be careful because it's very easy to make a mistake here. So minus 4.125. Right, let's just approximately put where that would be. So remember, we're referring to the bearing from O, the origin, and therefore my minus 0.75 minus 4.125 will be sort of like down here. And I want to find this angle here, that's the bearing. Therefore, let's focus on finding this angle here. And I can just say that that length is 0.75, that one is 4.125, therefore tan x is 0.75 over 4.125. $10.304, and therefore the bearing is going to then equal, just got to add on 180, which will give 190.3. I don't know, three significant figures sounds just a bit better. So 190 degrees. Well done.